Seroscience started to be active in this project relatively late. Our commitment was to contribute with data to the preclinical efficacy studies and also to provide toxicological and immunological evaluation of the final drug candidate or whatever product we can get. And if I need to summarize what did we learn from this experience, then I have to make two statements. Namely, the first one, where we have done relatively substantial work to date, is that different animal models and or experimental conditions may give contradicting results regarding the oral enteral efficacy of insulin nanoparticles. And this statement is based on our comparison of the duodenal efficacy of insulin zinc nanoparticles in pigs versus rats. And as Rudy Urbanic will give you tomorrow a detailed account of these experiments, unfortunately we find that the nanoparticles did not promote the efficacy or did not allow the efficacy of insulin, which data are contradicting to the rat data. And we do not know the reason at the moment. We'll do some more experiments to standardize the conditions. But one message is that the experimental conditions and the model is critical in making conclusions about the efficacy of an oral nanoparticle. The other conclusion is based more on considerations from the literature than our own work, namely that potential immune effects of oral insulin need to be considered. And there are several reasons for that. One is that, as we know, but little word is devoted to the fact that the intestine is a major immune organ. Actually, it contains more than 50% of the lymphocytes in the body, and it contains immense number of macrophages. So when we use the intestine to deliver drugs, we also need to at least consider potential immune side effects. And in fact, many nanomedicines have been shown to have adverse immune effects or become immunogenic. Immunogenicity meaning that the drug turns into a vaccine. And this slide illustrates how such transformation can occur if we consider that many nanomedicines actually resemble viruses. And for oral delivery, this comparison is made between poliovirus, which is widely used as a vaccine against poliomyelitis. It is well known, the Szebeni drops. And if you look at these particles, they are almost indistinguishable from some of the nanoparticles which have been developed for oral use. For example, the polymeric micelles incorporating paclitaxel, or the solid lipid nanoparticles incorporating raloxifene. So nanomedicines, because of their structure, can become immunogenic in the gut. Another interesting subject, we heard a lot about PEG. We heard about it in Dr. Haynes' lecture. We heard about the experiments in Maria's lab. And PEG is also used as one approach to oral insulin delivery, when it is complex to insulin, a pegylated oligolysine and oligoarginine complex is being tested in other labs. And regarding the PEG, it has been now, as you know, widely used. However, a PEG may not be inactive immunologically. As we heard already today, about 30% of humans have anti-PEG antibodies in their blood, and whose origin is not really known, perhaps oral exposure to the antigen. And actually, we have experimental data suggesting that these antibodies play a causal role in the hypersensitivity reactions to pegylated liposomes, doxil. And this is, although IV, the possibility that such pegylated nanoparticles get into the blood through oral delivery because of the enhancers, what we often add, is not, cannot be ruled out. And it is also known that pegylated derivatives are often major components of amphiphilic emulsifiers, like also known as surfactants or solubilizers or wetting agents, that have systemic toxicity in man and dogs. Have many data on that. And I'd like to remind you of the toxicity of sodium docusate and chemophore. Sodium docusate is actually a drug. It's called Colace. It's a laxative agent sold under many brand and generic names. Colace is the best known, but many others. And it is contraindicated for people with history of allergy because it causes severe allergic reactions, anaphylactic reactions, and this is caused or warned with the drug, whoever takes it. So although this is not PEG, but the fact that this is an emulsifier and PEGs can act as an emulsifier just shows the example that it can happen. In our own experiments, we injected chemophore in dogs and see major hemodynamic changes. This is systemic blood pressure, blood cell changes, and also injection of PEG, liposomal PEG to pigs, gives rise to huge antibody formation, anti-PEG IgM in the blood after 1 week. So these effects could also be present with oral administration. These have to be shown. And we have indeed shown that anti-PEG antibodies, pre-existing antibodies, are already present in the pigs, even before any exposure to PEG. So coming to the end, we have ongoing studies which will answer these immune questions. We are studying the immunogenicity of insulin nanoparticles using anti-insulin IgM and IgG as endpoint. We also look at the immunogenicity of pegylated liposomes, micelles, chemophore, orally administered to pigs, hoping that we can demonstrate the presence or absence of immunogenicity. And in some experiments, we also look at the impact of intestinal microbiota on immune response because it has been known to have an effect. So thank you. Actually, these are experiments undergoing, and we hope that we'll have time to finish them.
Thank you, Janos. Is there any question concerning the toxicology and immunology part? No question? I have a question. So we have a lot of anti-PEG antibody in the body. So why should we how should we consider it? Is it something normal, something warning?
Well, it can be dangerous if people are treated, particularly IV, with pegylated drugs, because that can lead to anaphylactic reactions or hypersensitive reactions. And this is what we model in pigs. It implies that if we have such antibodies, any drug which is pegylated, either IV or perhaps Paros, could be detrimental or toxic. That's the danger. This is the risk.